Hello and welcome to the UK Reigning Maths, and already in the second video we are finally going to solve some logarithmic equations. But before that, let me do a quick recap on logarithms, and for those of you who haven't watched the first video, go check it out in the description or in the notifications above. So there we go. We have logarithms log to base a of b. So what is the thing? The logarithm is a function that is looking for the index of a power, where we are given with the result of exponentiation and the base of a power. So let's say I have log to 8. So log to base 2 of 8. So what is this thing looking for? We have to find the index of a power given 2 and given result 8. So let us rewrite this using powers. So I have the result 8 on the right. So this is the result of exponentiation, what I get after I raise something to a power. And I have the base number 2. So I have 2 here on the bottom as the base number of a power. So what I'm now looking for is this exponent there on the top. And what exponent, what index of a power should I take to get an 8? Well, this should be exactly 3, because 2 raised to the third power is 8, which means that the whole log to base 2 of 8 is going to be 3. So now we are finally ready to solve some simple equations. So the idea to solving all of them is always the same. We have the log equation such as here, log to base 2 of x equals to 5. And what we want to do is we want to rewrite these log equations using powers. So how are we doing this? Using the definition of logarithms. So log to base 2 of x equals to 5. I'm going to rewrite this using definition of logarithm. So what does log say? I have base 2 and the result of exponentiation of x. So I have here my new equation with powers, and I have here x as a result. So this is the number that I get as a result of exponentiation. Okay, next I have base of a logarithm, which is also the base of a power. So this is a number 2 on the bottom. And I have here the number 5. What is log itself? The whole log is the exponent or the index of a power. So if we say that 5 equals to the index of a power, this means that we must put this 5 to the index because it is equal to the index. So we have x equals to 2 raised to the power of 5, which means that x is equal to 32, because 2 raised to the power of 5 is 32. So again, we had 5 equal to log, so we put this 5 up there as an exponent. Doing the very same thing here, we have log 5x equals to 3. This means that we have x as a result, and this time 5 as the base of the power. So we have here our 5 as here, we have our x as here, and we have our exponent 3. So the number in the index of a power, in the exponent of a power, should be this 3 right here. And this would mean that x is equal to 125. Moving forward, we are going to adjust our problem just a little bit. However, our plan is going to stay just the same. So this time we have x not in the result or not in the argument of the logarithm, but in the base of the logarithm. However, we're still doing the same thing. So we have logs to base x of 27 equals to 3. This is equivalent to, we're using the equivalency symbol, and this is just the same as having 27 as the result of exponentiation So I have 27 on the right as my result. And this time I have the base of exponent equals to x. So we have our x number on the bottom of the power. And this time we have a 3 as our index of a power. So we just put the 3 right here on the top. So we have x cubed equals to 27. Now we're asking ourselves, okay, what x should I take to have the result 27? And well, for those who know, this is going to be just the third root of 27 or just 3. Or you could just check 3 raised to the power of 3 is going to be 27. For those unsure how this works, go check out my video if I have one on roots. So, logarithm to the base x of 36 equals to 2. Doing the same trick as before, we have the result of exponentiation equal to 36. We have the base of the power x, and we have the index 2. So the log, the whole index is 2. X squared equals to 36, meaning that x is equal to the square root of 36, and it is equal to 6. Well, the most careful viewers could actually notice that there is something wrong with this equation here and with the way we solve it. So we have this the even equation, x squared equals to 36, and then we just say that, well, x is equal to 6. Something's wrong here. Usually we would have the second root, x equals to minus 6, because minus 6 square is still going to be minus 6 times minus 6, and this is going to be again 36. So actually, looking from this equation, this root, or this number x equal to minus 6, should actually be the root itself. However, the following question we're going to ask on the next page is, do all numbers in the logarithm make sense? And apparently no, this number is not going to be the root, because we cannot look at the logarithms of negative numbers. So moving on to the next page. So we are now asking ourselves this question: do all numbers make sense inside of a logarithm? And the answer, unfortunately or fortunately for mathematicians who love math, is a no. Why is that? To understand this, we are now going to look at one example. So for example, I have, let's say, log base 2 of minus 1. So the question is, can I have a number for that? Can I assign a certain value to this thing? So let's say I can, and this value is going to be an x, or an a, or any other number, or a letter. So say I assign a value to this one. Well, then we are going to do the very same trick we did before. We are going to rewrite this expression using powers. So I have result of exponentiation of minus 1. So I have minus 1 here on the right. I have base 2. And I have the index of a power x. Is there something wrong with this one? Or actually yes, because we know that the result of exponentiation to a real value is always going to be positive. So 2 raised to the x is always greater than 0, is always positive. Which means that I can never have that 2 to x is equal to minus 1. It is always positive, and a positive number is by definition not a negative number. Or the other way around, a negative number is not a positive number. So I actually cannot have this equation here, which means that this thing right here does not make any sense. Does not make any sense. So, what shall I do, and what is the general problem with this thing? The general problem is that I am not allowed to put a negative number in the argument, because I'm going to have the same problem as here. 2 raised to x is equal to minus 2. No, this is impossible. So minus 2, no. Minus 3 perhaps? No. Minus 1/2? Also no. It doesn't matter which number I have in this argument if this number is negative. Because if this is a negative number, and this equation here is unsolvable, and I cannot assign any value to the logarithm. So we have a conclusion that if we have, say, log 2 of x, or let's better say log 2 of b, this means that b has to be greater than 0, which means that we found a proper restriction to b. So if b is positive and everything is alright, if b is negative or a 0, then we are having some trouble. Or again, log ab, we have b greater than 0. So these are our restrictions on logs. Okay, but this is the restriction of an argument. Is there a restriction for the base number? So asking the similar question, but this time for a. And we find out that there actually is a restriction for a as well. However, this restriction is going to be just a little bit worse. We are going to have another extra detail here. So let's consider log, let's say this time we also take minus 1, and let's say we have a 2 and in the argument. So can we assign a value to this logarithm here? Let's try this one. Let's say it's going to be an x. And as before, we are trying to rewrite this one using powers. So I'm going to have the result of exponentiation 2 on the right, and I'm going to have the base of minus 1. So I'm going to have minus 1 raised to the x equals to 2. Whoa, this is impossible. And there are actually quite many reasons why this equation here can never have any roots in x. So first of all, if I have minus 1 and I raise it to a power, then I'm quite always going to have either minus 1 or 1. Moreover, or furthermore, if I'm raising minus 1 or a negative number to a real power, so like a 3.14 or the p or the square root of 2 to any real valued number, then I'm actually not allowed to do this. So the general problem is actually that I can't raise negative numbers to real powers. I'm actually not allowed to do this operation, and the reason for this one is a little bit harder than you can actually think. I'm going to have a separate video on that topic, which is quite beautiful actually. However, this is a problem. I cannot raise negative numbers to a real power, which again means that if I have a log of b to the base a, then I have the restriction on a saying that a is greater than 0. So I'm not allowed to take negative numbers. I'm not allowed to have a 0. Why is that? Because if I have log 0 of, let's say again 1, and we assign some value of x, well, this would mean that we have, as always, result of 1 base 0 and exponent log exponent or index x. But this means that 0 is equal to 1 because 0 raised to any power is again 0. And this here is possible as well. So I'm not allowed to take negative numbers, and I'm not allowed to take 0. Is this everything, or do I have another restriction? And it appears I have just one more subtle detail, because what is a not so obvious, or perhaps a very obvious number concerning exponentiation? So what number apart from 0 is very easy when we have exponents? And some of you might have actually guessed right, this is 1, because 1 raised to any power is going to be 1 again, just as with zeros. So if I have, let's say, log 1, 2, or any number that you would want to, and let's say I assign a value to this one again, so log base 1 of 2 is going to be x. By rewriting again, I stumble upon the same problem, that 2 is going to equal to 1 raised to x. And again, this is impossible, because this would imply, just as above, that 1 is equal to 2, which is again incorrect. So for the base number, I actually have two restrictions. I have that a base is greater than 0, is a positive number, and a is not equal to 1. So this is pretty much everything that I wanted to talk about in this video, but before we move on to the next one, let me do a quick summary of what we learned today. So first of all, we learned that the general idea of solving logarithmic equations, so the idea of solving log equations, is always the same. We rewrite the equation using powers. So this is the general idea of solving any logarithmic equation. We have to rewrite it using powers, because powers are just a little bit easier to grasp and understand than logarithm. Because, well, who likes all of these letters in mathematics? Some people do, but to understand things better, we rewrite them using powers. And the second thing we learn that we do exactly what we do in the first step, but we also remember about restrictions of log a b. So if I have log to base a of b, I have to remember about certain restrictions, and these restrictions are that the base number, so the a number, the base number, should be positive, it should be greater than 0, and it should not be equal to 1. Otherwise, the logarithm is not going to make any sense. The same one goes with the b, with the argument of the log. However, here we just have that the b should be positive. Anyway, thank you for watching this video, and in the next one we are going to solve much more equations. Many more equations for you. See you next time.